Hello, and welcome to the first video we're going to try to do during our little time where we're not meeting in school. Apologize, I'm a little bit under the weather. I do have a nasal congestion, but that's not a symptom of coronavirus, so we're okay. I'm going to be taking a look at, as you can see on the screen, series circuit. Then we'll go ahead and end this video and we'll take a look at parallel circuits. But some of the stuff we've already seen before, I just want to formalize it and show the Ohm's law equation works. So on the screen, you can see here that we have a circuit with 3 resistors set up. They're all different. I've got a 12 ohm, a 10 ohm, and an 8 ohm resistor. And they're hooked up to the standard 9-volt battery that you would get in the circuit construction kit on the PhET website. But I want to take a look at how the Ohm's law equation works. So just to refresh our memory, Ohm's law is the idea that voltage equals current multiplied by resistance, and that can work for a series circuit, and it can also, work for a series circuit as a whole or for each individual component within a circuit. So we're going to take a look at that in effect in the circuit, and then we're going to just work out a quick example problem. Not too many things on the screen. There we go. So if I turn on this circuit, you can see the conventional charge flow, the red arrows going, and I can use the voltmeter to measure how much electric potential or voltage there is for each resistor. So here I've got 3.6 volts being used by the 12 ohm resistor, and I can go over to my calculator here and use Ohm's law to calculate what the current should be. It should be voltage divided by resistance. So 3.6 divided by 12, and I get 0.3 amps of current. Let's try for the other resistor. I've got 3 volts, and 3 volts is for a 10 ohm resistor. So go back to my calculator, 3 divided by 10, I can do that one in my head, but just to get it on the screen there, we got 0.3 amps of current. So we said before that there's only one current in a series circuit, and we're seeing that here. It's the same current, same rate of charge flow through everything in the series circuit. And then last, we've got the 2.4 volts for our 8 ohm resistor. So calculate that, 2.4 divided by 8. And again, we get 0.3. So there's one current of 0.3 ohms everywhere in the circuit, just one current. Well, we can do that for each individual component, but let's do it for the whole battery. Let's see if it lines up and see if we can get any new information out of that. So if I measure the volts for the whole battery, it says 9 volts, which it's a 9-volt battery, that makes sense. But if I use Ohm's law, if I go back over here and I use this idea of Ohm's law, then the voltage for the whole battery, which is also the voltage for the whole circuit, should be equal to the current for the whole circuit multiplied by the resistance for the whole circuit. So what do we get if we do that calculation? If I've got 9 volts and I divide that by the current to get isolated resistance, divide by 0.3, I get 30. So according to this calculation, I should have a resistance for my whole circuit, V over I, which would be 9 volts over 0.3 amps, or 30 ohms of resistance. Well, what were my resistors? I have a 12, a 10, and an 8. Well, 8 and 10 makes 18, plus 12 makes 30. So the resistance in my circuit, the total resistance, is just all 3 resistors added up. And that's how we can calculate the series circuit resistance. So let's go ahead and formalize that and write this all down. For a series circuit, there's one single path for charge flow. So if I calculate the current in each of those resistors and call it I, it's the same current everywhere, including through the battery. So the voltage used by each of those is going to obey Ohm's law, and the total resistance of the circuit we can just get by adding up every single resistor. So series circuit total resistance, we say, is the sum of all resistances, sigma R, which in our case there's only 3 of them, so it's R1 plus R2 plus R3. But let's go ahead and calculate out what we would get if we had different resistors than what I had in that demonstration, and it was a 100-volt battery. So how about you take a moment to try to do that, and I'll get started in a second so you can pause the video. And I'll scroll down. There we go. So if we have the circuit up above, we have no way of calculating out what the current is unless we know what the total resistance is. So if we want to figure out the current, we need to know that that's for the whole circuit, for all the voltage sources, the battery, which means we need to know the resistance, that's the total for the whole circuit, which in our case is going to be the sum of all the resistors. So 10 ohms plus 20, oops, ran out of space there. Could move that down. 10 plus 20 plus 30, that would give us 60 ohms of total resistance. We've got a voltage from our battery of 100 volts, and we want to know what the current is. So using Ohm's law, dividing away, we get V over R would equal current, 100 divided by 60. And I'm terrible at mental math. Yep. 1.66666666. Or 1.67 amps. All right, so we'll pick up with some more stuff on parallel circuits, but that's all there is to series circuits.